Hello and welcome back to this new session of the Atos Smart tutorial. I'm Diego and today we are going to explore the latest communication protocol integrated into our proportional valve range, IO-Link. But first of all, what is IO-Link? IO-Link is a point-to-point communication standard that allows bidirectional data exchange between a PLC and a smart field devices, such as a sensor or a proportional valves. With the integration of IO-Links, Atos takes another big step forward in terms of digitalization. So, let's start. The IO-Link communication interface is available for direct and pilot-operated directional flow and pressure valves, and pressure valves direct and pilot-operated with built-in pressure transducer. IO-Link is available as well for directional valves and flow valves direct-operated with LVDT transducer and pilot-operated directional valves with LVDT transducers. Now let's take a closer look at the architecture of an IO-Link system. Of course, there is the PLC which manages the logic and the control of the entire automated process. The PLC communicates with the IO-Link master via a field-bus communication, such as Profinet, Ethernet IP, EtherCAT, and so on. The IO-Link master acts as a gateway between the PLC and the IO-Link devices through the IO-Link ports. The IO-Link master has different ports, and each one can connect to a single IO-Link device. From the master to the devices, communication takes place over unshielded standard cables, typically with M2F connectors. The IO-Link master can either be a module installed in the cabinet or an IP67 module installed directly on board of the machine. This structure reduces wiring and installation cost, simplifying commissioning and maintenance operation. The IO-Link protocol defines two types of ports. Class A, in which there are 3 wires, 2 of them provides 24 volt and up to 200 milliamps, and 1 wire is used for the digital data exchange. This class of port is mostly used for sensors. Then there is the Class B, in which we have 5 wires. 3 of them are equal to the Class A ports, but there are an additional 2 wires in which we have another power supply, and this is mostly used for actuators, like a proportional valve. Atos valves are Class B devices which require at least 50 watts, so be aware that you must use Class B ports or a Class A ports with a Y connection and an external power supply. Pay attention that without the P24 power supply, the Atos valve will not work at all, and even the communication will not be possible. Now let's take a closer look at how the IO-Link communication replaces the traditional analog control. In a standard setup, the PLC sends an analog signal, such as 0 to 10 volt or 4 to 20 milliamps, which is internally converted into a digital value. For example, a percentage of valves opening from -100 to +100%. With IO-Link, that conversion isn't necessary anymore. The PLC communicates directly in digital, sending native values straight to the valve's electronics, since in IO-Link valves there are no more analog connectors. This means no more signal interference and no more analog to digital conversion. Overall, this improves the quality of the signal exchange from the valve to the PLC, and thus the quality of the regulation. Moreover, IO-Links handle both cyclic data, which means continued data exchange from the valve and the PLC, and acyclic data, which means data exchange on request. Control and status words are fully described in the IO-Link manual available in My Atos area on our website. Watch the related tutorial if you don't know how to access it. Setpoint is the reference signal, thus what we are asking the valve to do, while actual signal is the feedback from the valve. According to the type of valve, the feedback could vary, so remember to check the specific valve at which you are connected with. Acyclic data are instead mostly related to the parameterization of the valve, such as bias setting, ramps, linearization, temperature reading, and so on. Let's have a look on how to integrate an IO-Link valve into your system. Install the IO-Link master. Connect it to the PLC using a supported field-bus protocol. Connect the valve to the IO-Link master. Check the technical tables or the quick start to correctly wire it. Okay, now import the IODD file into your PLC. The IODD files let your PLC recognize the valves and access its parameters. The IODD file is available in the download area of My Atos section, where you already downloaded the manual of IO-Link. Finally, you can configure the PLC and the valve, assign the correct port to the IO-Link devices, map the cyclic data, such as setpoint, control word, and configure acyclic parameters, such as ramps, gains, and limits. Now we have imported the IODD file using a third-party software, but according to the PLC that you have, the visualization could vary. Once the IODD file is imported, you will see the list of valve parameters that can be modified. Those parameters vary according to the valve connected width, and their specific function could not be straightforward to new users. Therefore, we strongly suggest, for commissioning, to double-check what you are writing and reading from the PLC through Atos Connect app or the Atos software. Remember that for the configuration phase it's mandatory to follow the PLC and the IO-Link master producer instructions. Now that everything is ready, we can connect our valve through the smartphone thanks to the Atos Connect app. If you are not aware on how to do it, please watch the related video. From the dashboard page, it is straightforward to see the status of the IO-Link communication. Moreover, by checking the signal section, it's super easy to understand if the communication between the PLC and the valve is properly working. Within the dedicated section of the app, it is also possible to configure the state machine that define the transition from operating state of the valve. There are two main modes: local, in which the valve behavior is automatically managed based on the power supply and internal alarm handling. This is useful for basic setup. IO-Link mode instead gives full control for the transition of the valve, for example from disabled to active directly from the PLC, and this is very useful in case of completely automated system. Now that everything is clarified, you can take full advantage of IO-Link capabilities. You can send digital command to control the valve, you can monitor in real time the temperature, the alarms, in order to have a full diagnostic of your system, and you can adjust in real time the parameter without stopping the machine. No analog wiring, no noise, just clean digital control with built-in diagnostic. Summarizing, why choosing the IO-Link communication for your Atos proportional valves? At first, remote configuration to parameterize the valve without stopping the machine. Live diagnostic to monitor the status of the valve. Simplified wiring thanks to the standard cable and standard connectors. Easy replacements. Automatic device recognition avoids reprogramming the valves in case of spare parts substitution. Thanks for watching and see you in the next Atos Smart tutorial.